So for our next speaker, we're going to have Anthony Randazzo from Expel.
Thank you. Really excited to be here. Thank you, ATT&CK team, for giving me the opportunity to, present, cloud things. Cloud is sort of this new frontier in security that we're starting to discover. So I'm happy to be here. All right. So again, my name is Anthony Randazzo. I lead the global response team here at Expel. What is Expel? Expel is a technology company that's built this SaaS application, the SaaS platform, to enable our 24/7 managed detection and response service. We integrate directly with the APIs of more than 45 different security vendors. Prior to Expel, I managed a Fortune 25 healthcare detection and response team. Before that, I dabbled in threat intelligence. I was a crimeware analyst at Eyesight Partners, which was subsequently acquired by FireEye. Just a quick disclaimer: I'm by no means a cloud expert, but I do frequently contribute our cloud detection and response findings to our blog, which you can see here. Feel free to hit that URL up for some cool tidbits. All right. So, what to expect from this presentation. We're all in security, and we all know that security is sort of this afterthought in our corporate technology environments. It shouldn't be a surprise to anybody that clouds sort of followed that similar path. To be honest, we're actually observing that much of cloud security is actually falling on people outside of traditional security teams like DevOps or cloud architecture, but it's not all doom and gloom. So this presentation is less about how we can use ATT&CK in its current form today, but how we can evolve and mature it. So today we're going to cover ATT&CK for cloud as we see it here, defending the control plane, a real world incident, and some other incidents, and how we've applied ATT&CK for cloud there, and then some takeaways. Just a quick note again on this presentation, it assumes that you have a limited knowledge of cloud. So apologies if there's anything that's elementary to the cloud experts out there, or if I've overlooked any foundational information for less experienced cloud security people. So ATT&CK for cloud's just over a year old. The community's been iterating as the world learns more about attackers in the cloud. Jen and the ATT&CK team released some really great changes last month, plus all the new sub techniques for cloud. So what exactly is ATT&CK for cloud? Simply put, it's a way to communicate how attackers misuse and abuse cloud services. So we see this as two big buckets today. We have infrastructure as a service and we have software as a service. So infrastructure as a service are those large cloud providers like AWS, Azure, Google. The attack surface for these infrastructure as a service are similar because they're providing almost the same services as each other. They just use different names. When we talk about software as a service, these are cloud services that you don't have to manage any infrastructure or a platform. The big ones we all know: Salesforce, ServiceNow, Zoom, Workday, GitHub, etc. The attack surfaces with these, there's a little bit more variance, but are likely going to be concerned with the identity and access management of those of that software and the service APIs for them. So how is cloud different from the rest of enterprise attack? So there's clearly enough differences in the attack surfaces of each of the operating systems. So Linux, Windows, Mac, that they warrant their own matrix. But what makes the cloud matrices or the cloud providers different? It's not really that much. So identity and access management is the primary differentiator in each of these cloud platforms. They all provide the same services. It's how you access those services at their core. So each platform has a different identity and access management, and we'd argue that much of the learning curve actually lies with the IAM, the identity and access management for security practitioners. So what makes the Cloud matrices similar, and this is the big thing here. Each of them have what we call a control or a management plane. This is a similar attack surface across each of those providers. So the infrastructure as a service users, we use this control plane to manage the various cloud resources via APIs. And this is where we're actually seeing attackers abuse and misuse cloud services. And it'll be one of the main focuses of this presentation. So, considering the differences and similarities today, is this enough for each of these cloud providers to warrant their own matrix? Today we have an AWS matrix, an Azure matrix, and a GCP matrix. And the answer is actually no. So last month, Jen and the attack team announced a consolidation from one matrix down, or from the 3 matrices down to 1 matrix based on what we know about attackers today. So let's zoom in on the the cloud attack surfaces. There's lots of new technology in the cloud that didn't even exist 10 years ago, and there's quite a few attack surfaces at the same time. So we already mentioned that the control plane, the management plane. It's a way to abstract administration away from all of these various services using one thing. We have Kubernetes and its control plane for management. Kubernetes being a way to manage your containerized environment. I'm not an expert by any means on Kubernetes, so I will stop there. Storage services like S3 or Azure Blob Service or Google Cloud Service. This is your hard drives in the cloud. The compute resources, right? So all of the VMs that run in the cloud. So Amazon EC2, Azure VM. This is where all of our applications are running that are not in containerized or even in containerized environments. Cloud databases and AWS, RDS, Redshift, etc. So why did we choose to focus on this control plane given we know about all of these different attack surfaces? A few reasons. So we believed it would, our theory was that it would likely be easier to spot attacker fingerprints. And I'll get more on this soon with regards to like the data that we use to spot those fingerprints. But it's also a super high risk for any businesses. If you lose the access keys to your control plane, it could potentially be like having domain admin for a Windows environment. There's another reason there's not a ton of traction with EDR in the cloud. There's very few vendors that are actually spending a ton of effort here, and there's even less customers deploying it. It could be possibly due to the reason I mentioned before of cloud security falling on other teams like DevOps. And lastly, the migration to containerized and serverless cloud compute. So it's important to know what we're responsible for versus what our cloud providers are responsible for regarding security. So this is the shared responsibility model for cloud security. Each provider has one, and they're all relatively the same. This is AWS's, which much of the rest of this presentation will be the focus of. But what we found out through the shared responsibility model is that the cloud provider is actually responsible for very little security, and I think this is kind of a misconception that people have by migrating to the cloud. That there's inherently more security. It's definitely true in some instances, but generally speaking, it's not. So on this diagram, the blue mostly represents all the different cloud services that each provider offers. That's EC2 and VPC, S3 storage, IAM, RDS, all these different acronyms that are services in AWS. All of these services are managed by the control plane, and the control plane is made up of many different APIs to access each service. So there's 3 ways that you can actually access those services through the control plane. First, the web UI, that's console.aws.amazon.com, right? Next is the CLI, which is the command line interface through some shell. This isn't commonly used. And then we have programmatic access through software development kits, SDKs. And this is the most common, right? Because most AWS resources are managed programmatically through infrastructure as code like Terraform or CloudFormation. But we do know that the cloud control plane is actually a shared responsibility. AWS tries to make the APIs, inherently secure, and you can make the debate as to whether there's vulnerabilities or there are features. But they're also providing protection through paid services like Amazon Guard Duty. So here is a brief story of our threat detection journey in AWS. We know we wanted to focus on defending the control plane, but where do we start? So first we asked, what native detection capabilities or services does AWS offer for the control plane? The answer is Guard Duty. And there's about 50 or so use cases or Guard Duty findings for the control plane that offers threat detection in that service. So there's definitely some great detections in Guard Duty, but some are less helpful, just like any security product. We actually have a couple of blogs highlighting, the value we see in Guard Duty. So knowing that, what are our gaps? We have Guard Duty. What are the gaps and how we defend this control plane? There's almost 10,000 different APIs, so there's probably quite a few. Shout out to Scott at Summit Route, for providing the plethora of AWS security resources we use to, sort of drive this detection and response strategy as well. So what's next? Now we need to find the data that we have available to us to develop that detection strategy for the control plane. And with that, we're sort of off to CloudTrail now. So CloudTrail is the native AWS logging for our control plane. So we've got all of our CloudTrail data. How do we start building threat detections? What are our use cases? What are our threat models? So we decided to look at offensive security tools that abused or misused the control plane in AWS. These are, penetration testing frameworks. PACU is and probably still is the most well-known today. This was open source from the good folks over at Rhino Security Labs. After we did this, we built experimental detections on the CloudTrail data to see if, one, attackers were actually using these tools, which some were, or two, are the attackers abusing or misusing the APIs that were identified in these OSTs in other ways. So from there, we iterated, we tuned, enriched, contextualized these detections as we learned more about real attackers. And evidently, we caught a bunch of penetration testers and red team along the way. So this is an actual attack that Expel detected and responded to. It's what I would call an unconventional coin miner because, when we generally see coin miner, it's a result of like an RCE exploitation on some web application, right? In this instance, we have an attacker that identified root AWS access keys in a GitHub repo or wherever it was, and then used those keys we saw from an unusual IP from that environment. So let's talk about root access key risk a little bit. Root access key the root access key risk allows an attacker to have complete control of a potentially production environment. This is root access, unless there are some controls that you can implement to reduce access to root keys, but in most instances it's complete control of that AWS account. So basically the domain admin of the AWS account. So what did the attacker do with those keys? He or she created multiple extra large EC2s and associated SSH key pairs for those EC2 instances. Those are VMs. Then they modified the VPC security groups, the virtual firewall, to allow any access. And this was all done via an automated bot written in one of the AWS SDKs, the software development kits. In this instance, it was Golang. So a whole bot that was written in Go. So those SSH keys were then passed off to access those new EC2s that were spun up to install the coin miners. This is where we actually saw Guard Duty come in. So Guard Duty's detections are based on 3 data sets. It's CloudTrail, which is the control plane logs. your DNS in AWS and your VPC flow logs, which is your net flow. But keep in mind that this guard duty alert is actually an EC2 finding and is not for the control plane. This finding is actually meant to identify evil in your EC2 based on like DNS or flow traffic. But at the end of the day, it was great correlation for our analysts. You know, with this story painted, or this picture painted, you know, this leads into how we visualize you know, MITRE attack for cloud. So let's get into that a bit. So what we have here is a model of everything that occurred with the AWS root keys before those SSH keys were used to authenticate to EC2. Think of it as two phases of the attack. But this also highlights how little we know about attacks on the infrastructure as service platforms, AWS, GCP, Azure. You know, there's lots of maturity in the other enterprise matrices. So to detect an attacker here, we're relying on our security signal from those control planes. So for AWS, it's CloudTrail. And GCP, it's the admin activity, the system event, and the data access audit logs. It's the activity logs in Azure. All of these control plane logs are not created equal, though. You got to think that AWS has been around for probably, you know, it's got 5 more years of maturity than GCP. So naturally, the AWS control plane logs are significantly more mature than GCP in our experience. So here is what we call the second phase of the attack. Everything after those SSH keys were passed to the bot to install the coin miners. And what you're seeing here is, you know, the enterprise Linux matrix. So the first thing we observe is, you know, obviously a much more well understood and mature attack surface than attack for cloud. But interestingly, this is almost the same attack mapping as we sort of mentioned earlier with RCE exploitation of a web application to install a coin miner. So we actually have quite a few more examples of attackers hopping around between the cloud and the enterprise Windows or Linux matrices. So similar to the attack we described earlier, we have another instance of an attacker, except this came from the AWS CLI. So it was more hands-on keyboard, but it was multiple compromised keys, and the attacker imported their own SSH keys to access the EC2. Next, we had you know, Python SDK access of AWS System Security Manager. You know, SSM is the SCCM of AWS, and by default, this provides pseudo Linux access. While this wasn't a real attacker, it was a pretty sophisticated red team. Next, we have you know, server-side request forgery exploitation, so SSRF. We see these are the ones we see the most, or we used to see most commonly in the news. You know, similar to, you know, many high-profile breaches like Capital One. Essentially, the EC2 instance, the VM, has credential access to the control plane through the instance metadata service. You know, that provides data to the EC2 that it needs to do its thing. But essentially, you can take those EC2 instance credentials that may be over permissioned and can use those to do malicious, you know, abuse, misuse the control plane, or even use them to escalate privileges. And lastly, we saw an RDS database ransom. What this was actually a broad scan against open Postgres databases. It wasn't quite that hop between matrices. But what was interesting was that we were able to identify how the database was ransomed through the CloudTrail control plane logs. And to do this, we actually, in the CloudTrail logs, we saw when the password was changed and that RDS instance was, you know, clearly exposed to the open internet. So based on our detection response experience in AWS here at Expel, we developed this really cool mind map for attack, you know, for the APIs that we observed being abused or misused over the last 18 plus months. So keep in mind that many of these have yet to be modeled into Attack for Cloud, but we're definitely working with Jen and the MITRE folks to get some of the stuff documented and modeled in. But if you would like a copy, the link's there, and we're happy to share it with everybody. So let's talk about some of the takeaways. There's clearly lots of attack surface in the cloud. But there's also lots of opportunity to better understand all of the enterprise matrices and improve cloud in particular. We don't know what we don't know. There's a lot of public detections out there against CloudTrail, but many of these, actually the vast majority of these are for what we would call a risky configuration. So an S3 bucket exposed to the internet or an RDS bucket exposed to the internet. A risky configuration change on your VPC security group. And these aren't really pushing the envelope. It's just a lot of alerts that don't tell us a whole lot. What we need are more threat-centric detections. We need more experimentation. Again, this is sort of that new frontier. We need to try a bunch of different things to sort of see what sticks. And lastly, attack automation, I think, is really here to stay. Almost every example that I discussed was an automated attack, with the exception of the one attacker that was using the CLI. But this limits our ability to respond rapidly attacks, and it almost implies that we have to sort of shift to this automated response framework in the cloud. So that's all I had today. I hope that this is very insightful for everybody. I know this is a lot of new material and a lot of new concepts to people. 18 months ago, I had virtually no experience in the cloud. So let me be a lesson to anybody else that it's easy to spin up and learn these things. But I'm happy to elaborate on anything in Slack. And thanks again for having me here today, MITRE.
Thanks for sharing. That was fantastic. And like you said, a lot of us are kind of in the same boat where we know of the risk here, we know of the growing threat, but just getting those first steps in the cloud, is such a learning curve. So we definitely appreciate all your insight. We had a lot of great questions building up in Slack. So definitely hop over there. Yeah, some really good ones. I'm gonna poke your mind a little bit. So you mentioned before the shared responsibility. I think that's not something necessarily that's new. Even in the traditional enterprise environment, there's some kind of spillage between the users and the actual vendors. But what are your thoughts on how, as a security practitioner, I'm gonna use the same example from Ali, as a small SOC, how do I work with the big vendors? I'm thinking about things like metadata services, things that maybe are outside of my control. What are your suggestions here for as a security practitioner, how can I augment those services as well as work with the vendors to actually increase the security as we learn more about these threats?
Yeah, it's tough as a small shop because as we all know, we're stretched pretty thin as it is from a security perspective. I think it's important, when we which the community is doing a very good job at, but when we identify these things that are inherently problematic, particularly metadata service, I'll use that as an example. So the instance metadata service. After the Capital One breach, there was so much pressure on AWS to make that thing more secure because it was causing so many problems that they actually they revealed instant metadata service version 2, which eliminates a lot of the risk there. However, it does take an army to migrate all your applications and everything over to the new instance metadata service. So. Yeah, it's tricky. It's tricky for sure.
Makes a lot of sense. And one of the interesting things that you mentioned was kind of the overlap between matrices. Like you said, I think one of the examples you shared was, cloud was the beginning of the breach and it quickly jumped over to Linux. But thinking about, for those that are kind of more focused on the native cloud attacks, I think some of the trends we've seen is a lot of that has been either ransomware or just complete exfiltration, just, attacking data in some way, either holding hostage or stealing it. What are your trends, or what do you kind of see as on the horizon in terms of those cloud native attacks?
Sure. There's a couple ways I can answer this. I can be an optimist or an alarmist. So we don't know what we don't know in the cloud with regards to how, because the threat detection and monitoring really isn't there. I don't think there's a ton of organizations that are doing this. But once we learn more about attackers, and once that stuff starts being socialized a little bit more, I'm almost curious to see if more attackers actually migrate to attacking things like the control plane. What's interesting about the coin miner attack is that attacker could have monetized those root access keys significantly more than installing a few coin miners, right? They had control of what could have been a production environment, right? But I think that, you know, attackers have risk management as well. So how much heat do they want to bring on themselves? But again, most of this stuff is automated. So there's a preconceived notion of what the attacker wants to achieve.
And then the final question I had for you is, personally, I've worked with the cloud team at ATT&CKing and kind of helping mature that model. So we definitely appreciate everything you guys have contributed and kind of work with us to build that out. But like one of the things you keep mentioning is that, you know, we're all in this together. You know, all of this is maturing at the same time. The tradecraft from adversaries is growing, as well as, you know, our ability to detect these things, you know, harden them, and then, like you said, share information about, you know, what adversaries are actually doing. What advice can you give to, you know, the community listening on how we can work together to actually, like, you know, reach that end state of, you know, more secure cloud development and more secure cloud deployments?
Yeah, so I think it'll evolve over time. I think the cloud is still relatively immature, especially from a security perspective. I mentioned how a lot of cloud security falls on teams that are outside of traditional security. So I think as that matures a little bit more, we'll get a better grasp of things. But you know, with that being said, there is the information sharing is really important here. I think that's how, you know, the security community as a whole has evolved. Everything. Look how you know, mature attack for Linux and attack for Windows is. Those are contributions from a bunch of people trying to work together for a collective goal. So I think, yeah, as long as we're you know, continuing to help each other, we'll get there.
Yep, we're all in this together. It's all about the community. So thanks again for your presentation. Like you said, definitely hop over to Slack. There's some great questions building up there. Definitely want some more insights from you. But with that, I'm going to turn it back over to Adam to introduce our next speaker. Thanks again, Anthony.
Yeah, and thank you both of you again.